Okay, hello everybody. Thank you for staying this long at Devox to listen to my talk. Let me just get started. I probably win the award for the longest slide talk ever. That's a big title. This talk's generally going to be about microservices, Docker, Kubernetes, and Jenkins, all in one talk. Okay, so software's eating the world. Pretty much every business now has kind of realized it's mostly a software business. Cisco now say they're not a networking company, they're a software company. Most car manufacturers now spend a lot of time designing cars with software and implementing cars with software, self-driving cars, anti-lock brakes, and so on and so forth. So pretty much most businesses now need to focus on how to develop software and how to deliver business value through software quickly. Most businesses now are worried about the Uber effect of any minute now there might be a small startup that knows how to deliver software well, coming into a new business and taking over established businesses that haven't quite figured out how to go quickly with software. So we're all kind of under pressure to figure out how to deliver business value quickly with software. Now, one of the problems is with software, it's very easy to write software. It's very hard to write the correct software. Studies have shown that often only a third of software we write has positive business value, right? We guess of stuff that we need to write to help things, but most of the time we're wrong. So the only the worst thing you can do is ask customers what they need, right? If you ask customers what they need, that's almost certainly not what they really want, right? So the only way to really deliver significant business value is by iterating and going quickly and doing lots of small incremental jumps, getting feedback and seeing what works, what really helps your bottom line of your business, what really helps make customers happy. So we all need to get into the habit of going quickly, delivering software. So we need to aim for speed, iteration, and continuous improvement, right? So the days of disappearing into your bunker for a year, writing page after page of documentation to then spend another year implementing the documentation and then another year releasing, those days are gone. We need to go quickly and iterate. So we're all aiming for this kind of continuous improvement cycle. We want to be doing continuous integration. We want to do continuous delivery. Then we want to do continuous testing and continuous operations and continuous assessment. So we want lots and lots of these feedback loops where we can keep iterating and developing and getting constant feedback all the way through. The best way we've figured out so far of how to go quickly is by continuous delivery of containerized microservices. Now, you've probably heard microservices a couple of times at this conference already. Microservices seems to be all the rage these days. For me, microservices are just two things. It's about speed. It's about how do you go quick? How do you take a large group of people, like more than 6? How do you take a reasonably large number of people writing software? And how do you go quickly and scale your organization so you deliver real business value quickly? And for me, there's two really parts to microservice. One is you decouple your systems into smaller pieces, and each one of those pieces has its own independent release cycle. Now, pretty much every team I've ever worked with, every job I've ever done in IT over the last 2 decades, every system that's reasonably complicated, the first thing everybody does is draw on a whiteboard or a big piece of paper lots of boxes. And we label all the boxes with names and symbols and wacky planet names or whatever, and we draw lots of diagrams and arrows between everything. So monoliths have always been decomposed into boxes, right? There's nothing new about decomposing functionality. What's new about microservices is each one of those boxes has its own release cycle, right? That's the new thing about microservices. As soon as if you release all of the boxes in one release, that's a monolith, right? Because all the pieces are tightly bound together, and to do a release, you have to test everything. And then you have to all agree when you're going to release everything, and you have to wait for everything to be just so before you can release, and that's when things get slow and complex. The microservices approach is every box on that diagram has its own team and release cycle. So one part of it is split your software into pieces and release them independently. The other part of it is organizational. Rather than having one monster team and then dividing your team up into testers and developers and business analysts and UX people, you split your teams and align them to microservices. So one team looks after the entire life cycle of a microservice. So one team specifies, plans, designs, implements, and tests, and most importantly, operates that software in production. I've been doing open source for far too long, really, I think, a long time. One of the interesting things about open source is the mere act of making your source code public tends to raise the bar a bit about the quality of the code, right? I've seen some truly horrendous code that's proprietary, because not many people are ever going to see it. People don't really go the extra mile and really polish the code to make it like clean and well documented and well tested. So by doing open source code, you tend to raise the bar in software quality. In a similar way with microservices, if you're running the code yourself, you're more likely to put the extra mile in to make your code easy to understand, easy to diagnose, and easy to manage, right? If you're on the line to make something work in production, you're going to err on the side of caution and make something easy to run and easy to comprehend, rather than really crazy with a million features in there that nobody quite understands, right? If all you do is throw code over the wall and it's some other poor person's job to make that run in production, you're going to care less, right? And you're going to just chuck sloppy code over the wall. So the mere act of splitting code into independent releases and then having one team that develops, tests, and runs the software means we all go quicker, and we make software that's generally more reliable because you write software in a more manageable way, right? One of the best tricks with microservices is go to production on the very first day, and then every time you make a change, do a rolling upgrade to production. So everyone in the team gets used to running stuff in production. Don't develop in a vacuum for 2 years and then think, yeah, what's production anyways? And then suddenly go through all of this pain of how do you even run things, right? So the more we can work in a microservice way, splitting things into multiple releases and splitting teams to be aligned with microservices, the faster we can go, right? Another way I like to look at microservices is it's a bit like concurrent programming. By having lots of teams work together on the same release, you're adding like mutual exclusive locks everywhere, right? I can't release until this other team decides to release, and then this other team decides to release, and we're all sat there blocked, waiting for one team to be ready. As soon as you go microservices, each team can just release whenever they want, right? Now, one of the problems of microservices is when we start moving to a microservice world, in a monolith kind of world, we might release a couple of times a year. Everything's kind of fine. If we're only doing 4 releases a year, it doesn't matter if it takes 3 weeks to get a release out the door. And if everything's manual, it doesn't really matter because you do it a couple of times a year. As soon as you go microservices are a little bit like crack. The first couple seem really awesome. Before you know it, you've got microservices everywhere, and you've got hundreds of the damn things, right? As soon as you have like 100 microservices, and it usually tends towards 1,000, maybe thousands of microservices, imagine you have 1,000 microservices and they're all releasing 3 times a day, right? That's a lot of releases, right? That's a lot of stuff that's happening. You don't want to be doing manual releases anymore, right? That doesn't scale. As soon as you're going on to several releases a day per microservice across hundreds or thousands of microservices, you might be doing 3,000 releases a day, right? We can't be doing that stuff manual anymore. So once we start moving towards a microservice world, we need to automate everything about the entire end-to-end life cycle. So from creating a microservice, to testing it, to building it, to releasing it, to deploying it, to managing it, we kind of need to automate the entire pipeline. I'd even argue, don't even really start microservices until you've figured out how to automate one of them. Because before you know it, you're going to have all this technical debt of actually releasing something that you're going to be going so slow, you might as well just fix your automation first before you end up with 100 microservices to deploy, right? We've been on a journey, my team that I work on has been on a similar journey. We started with one monolith, one repo. It was quite easy to release. We now have 200 repos, and it's much more complicated to release because there's 200 things to release and orchestrate. For a while, we did it manually, and that was super painful. It would take one person like 5 days just to do a release. And it was horrible, and you'd just be sat there writing little shell scripts and pressing buttons, and it was just truly horrific. Now we've automated everything, so we just sit there watching software fly out the door, and it's awesome, right? So if there's only one thing you take from this talk, if you're thinking about working in the microservices way, focus on automation first, because you're going to be wasting a ton of time doing releases and trying to comprehend what's going on, right? Now, what we found on our microservice journey is we wanted some help, right? So that anybody in the team could make a new microservice, they could take that microservice to production really quickly, ideally in a few clicks, and then all of the steps in that microservice's lifetime, every time you do a commit, every time you run a test, every time you do a new deploy, we want to try optimize and not automate the whole pipeline. So what we found is we wanted a developer platform that helps us do microservices, develop them, test them, stage them, and release them to production. So we ended up piecing together a whole bunch of open source to give us this open source developer platform, which we call Fabricate with an 8. Fabricate as in to fabricate microservices, to make the microservices. But it's a number 8 because it's a little URL on the internet. So Fabricate, 8 isn't a version, it's just a play on words. So fabricate.io is the website. What I thought I'd do is I'd just show you it in action. I'll show you Fabricate running right now, and I'll create a few microservices and show you through pipelines. So you get the idea of what it's like to use Fabricate. Then I'll walk through how it all kind of works under the covers. What are the technologies we use to implement Fabricate, how it all kind of works. One of the lovely things about Fabricate is it's all completely modular, so you can take any pieces you like. And most of the core components are totally reusable, so you can use all of it or just some of it. It's all cool. So what are the main features of Fabricate? So we have wizards to help you create microservices. So once you start on a microservice journey, you're probably going to do lots of experiments, writing lots of little microservices that do lots of kind of different things. And you want a quick, easy way of spinning up new microservices. They might be using Spring Boot. They might be using Wildfly Swarm, maybe Vertex. You might like Node.js. You might like Golang. You might like Python or Ruby or Swift or .NET. It doesn't really matter. It's up to you. Pick whatever language and framework and stuff you want. But we've got wizards for all of that kind of stuff to create projects quickly. Each of the projects we create automatically know how to build themselves. And by that, I mean generate an immutable Docker image for packaging. I'll talk about that a bit later. But we basically make immutable Docker images for each microservice. Each one is then versioned and immutable, and we can then do rolling upgrades by label, really nice and easily. We also use something called Kubernetes, which I'll describe a bit later. Don't worry about the Kubernetes bit just yet. But that deals with all the orchestration and load balancing and scaling and all that kind of malarkey. So as part of the build step, we generate all of the manifest files that you need with Kubernetes to deploy things. We have this release mechanism, which we basically rely on Kubernetes mechanisms for doing rolling upgrades. Different people want to do releases in different ways, right? Some people want to do like blue-green, where they want to build if you're rolling out a new version of your microservice, you want to deploy, let's say you're running, I don't know, 3 Tomcats to do your microservice. You might want to deploy 3 new Tomcats with the new version in, and then you check it's up and everything, and then you switch the load balancer across, and then you tear down the old one. So you might want to do the blue-green thing, where you spin up a whole copy of the system again with a new version, and then switch your load balancer across, and if you don't like it, you can switch back. Kubernetes has a much more clever approach where you can do incremental load balances. So you can say, hey, I'm running 3 of the old one, run 1 of the new ones. Is it looking okay? Give it some traffic. Is it looking fine? Yeah, that's okay. Try 2, and then gradually move the lever across and run more and more of the new one. And if no alarm bells go off and no errors start appearing, go completely to the new one, and at any point in time, you can roll back again. So we have all this automated stuff to roll new software out and roll it back again. You can get clever and do kind of A/B testing, where you can say we're going to send a specific amount of traffic to the new service, see how it affects our core performance metrics and KPIs and whatnot. Do the number of orders go up or down? If they go down, roll back pretty quickly, right? If the numbers go up, awesome, roll over. So you can look at how your new software behaves and use that as a decision whether you keep it or you kind of roll back. So those are the releasing pieces. Management. If you're releasing a microservice to production and you have no idea what it's doing in terms of like logs and metrics and alerts, I would argue you shouldn't ever go to production, right? If you're flying blind, you're kind of lost. So what you really want is every one of your containers that's running in production. You want centralized logs and centralized metrics and alerting so you know exactly what's happening. Every time you do a new release, if all of a sudden there's loads of exceptions everywhere and things are failing and you're getting 404s on your web server and whatnot, you need to know about that stuff early, right? Ideally, you'd run that in, say, a staging environment first or a testing environment, so you'd weed out most of the common problems before you hit production, right? We want to minimize downtime for real end users. So we want centralized logging and centralized metrics and alerting. Finally, you want feedback. One of the most complex things as you start moving towards a microservices world is you've got tens, hundreds of things releasing all the time. Most team only focus on one small piece of the picture. Nobody really knows what's going on globally anymore. So you need feedback, visualization, dashboards, so that you can understand what each team's doing. If you're consuming some microservices from other teams, you want to get visualization of what that other team's doing. If all of a sudden your microservice is failing, you might want to know, well, the other team's just done a release right now. Maybe that could be the cause. So being able to visualize what other teams are doing in a simple, automated way, so each team can still work quickly, but each team can also get information about all the other teams and so forth. So finally, platform. These days, the public cloud is really trendy, and lots of people want to go to Amazon and Google and Azure and whatnot. But for various financial or regulatory reasons, a lot of people can't go on the public cloud, or they've spent so much money on their data center they feel like they have to use it, which is reasonable, or they just want to use a private data center, or you've just got a few boxes under your desk that you want to use as part of your cloud strategy. So what we want is a cloud that works on any machine, whether it's laptop, random stuff under your desk, on-premise data center or public cloud, or a hybrid, right? You might want to use the public cloud for testing, and then just use your data center for production, or vice versa. You might want to use a public cloud for production and your data center as a test bed. All of these things should be supported. So we want something that works on any machines, right, which is cool. So that's generally the kind of features we're aiming for in this thing. The best thing I could do right now is fabricate some microservices with Fabricate to show you it all kind of working. As I create some microservices, I'll describe a bit about what's going on behind the scenes. And then once the demo's out the way, I'll describe how you can run this on your laptop, and then what all the technology is under the covers. Okay, so I've installed Fabricate on my laptop. I'll tell you how to do that after the demo. And this is the kind of the homepage. Before I dive in and create some microservices, I'm just going to show you the runtime view. So this is the Fabricate console looking at a Kubernetes cluster. I'll talk about Kubernetes later, but basically this is a cloud. It happens to be in one VM on my laptop, but this is a cloud that runs containers. Out of the box, Fabricate comes with a whole bunch of different tools pre-configured for you. I don't know if you've ever tried this yourself, but it takes quite a while to take, say, Jenkins and Nexus and get them to work together, so that Nexus is a download proxy and also releases go to Nexus. So what we've done is take all these open source software tools and just package them together so they just work outside the box. You don't have to configure anything. You don't have to edit any config files or anything. Everything just kind of works. So the out-of-the-box tools, if you look at the bottom, you see there's Jenkins right at the bottom. We have a Jenkins, which is a normal Jenkins 2 image. We'll see lots of Jenkins later. I'll talk about that in a minute. We've got a Nexus at the bottom, which is for artifact repository. So whenever we release like jars or wars or NPM packages or Kubernetes manifest files or JSON schemas or any of those kind of things, that goes in a Nexus and is versioned and everything. We use a Docker registry for the actual Docker images. We've got this thing called GOGS, which I'll talk about a bit later, but that's for on-premise Git hosting. If you're an open source company, you probably put all of your source code on public GitHub. If you're a more commercial company, you might not open source everything, so you might want to keep some of your source code not online. So you might want to use GitHub Enterprise, you might use Atlassian Stash or GitLab. We ship out the box with something called GOGS, which is a Golang open source version of GitHub. So it runs on-premise in one small Docker container, which is pretty nice. But we also support other other Git services, if you like. We've got this thing called Fabricate Forge, which is a project wizard, which I'll show you in action in a moment, and a bunch of other kind of microservices that helps all this stuff run. So that's our development environment. It's basically a Kubernetes cluster with a bunch of open source software tools. What I'm going to do now is go to the team dashboard, and I'm going to create a new application from scratch. So I'll just try to figure out why my preview thing keeps popping up. Oh, OK. Let me just create that. Excuse me. Delete copy. Go away. Just disappear. Esther. Oh, my God. OK, just ignore that. OK. I had an interesting Esther experience getting into the States this trip. OK, so let's create a new microservice. Now, you've got two options. You might have some source code already that you want to import from Git, which we could do. Or we're going to start from scratch. We're going to say, hey, we've got a wacky new idea for a new microservice. Let's do something with, say, Spring Boot. So you click the Create New App. We have a whole plethora of different wizards here. I'm not going to walk you through all of the wizards, but we have wizards for Spring Boot, where you can do the stat.spring.io kind of crack, or there's the Wildfly Swarm thing that lets you pick all the Wildfly Swarm dependencies, or there's a similar thing for Vertex. There's a Camel integration wizard. There's Django, .NET, Swift, Rails, even PHP. There's Golang if you want to be really hipster. We should add a Rust just to be like uber hipster. But we're going to do just a vanilla Spring Boot microservice in this demo. And I'm going to call it, can you see at the bottom here, DevOps US. And I'm going to click Next. So now I've chosen the kind of project, which you'll see in a minute. I'll show you the source code. It's just a Spring Boot, Spring Web MVC kind of app. Now it's going to, hopefully, give us a list of pipelines to choose from. Now, I'll explain what pipelines are a little bit later in the talk, but think of pipelines as these are the steps that each version of each microservice goes through to get to production. Now, I'll talk about these in detail for now, but I'm going to click the one that goes from testing to staging to production with human approval, and I'm going to click Next. Now, this is all running on my laptop, and my laptop isn't the fastest thing in the world. It's a little bit slow. So I'll talk about what's happening behind the covers while this builds. It's going to take a couple of minutes to go all the way through the pipeline. So you'll notice right at the bottom, it's already kicked off a build. So what's happened under the covers is we've generated the source code for this new microservice. We've created a Git repository. We've pushed the Git repository into the GOGS server. So we've got a new Git repository with the source code inside that we can then clone and edit and Git push back in any IDE or whatever, or tool. We've also then chosen a pipeline, which is a Jenkins pipeline file. That pipeline defines a Jenkins build that will then build the Docker image, generate the Kubernetes manifest, run some system tests, which I'll talk about the system tests later. It will then stage the microservice into the staging environment, and then on human approval, it will go to production. Oh, crap. No. No, you're kidding me. This is the first time this demo's ever failed. Oh, my God. OK, let me just try this other microservice that I created earlier. OK. Damn. OK, I might have to go to a video if this doesn't work. Let's try this again. I knew I should have tested my demo. OK, let's see if this works. Let me show you what's been happening behind the covers, and let's pray that this build actually works. Otherwise, this demo is going to be quite quick. So we've generated the Git repository. Let me show you the Git repository first. We've got a little tool, drop-down tool thing here. Now, we've only got 3 developer tools right now. There's GOGS for the Git hosting. There's Jenkins for the pipeline. Oh, my God, the build's failing again. Shit. OK, it's video time. Let me go to quick time. Something bad has happened. Where did I put the video? Oh, crap. Crap. OK. Yeah, let's just play it straight on Vimeo. Blog, Is the internet working? Yeah, I'm still on the internet. Yeah, OK, cool. Google container, yeah, cool. Let's watch it on Vimeo. OK, cool. Let's play it. No sound, just in case it's embarrassing. Go full screen. Let's see if the full screen works. Yeah, OK, phew. I'm going to fast forward this a bit. So what this video does, this video is an example of starting from scratch. I'm going to fast forward a bit, but this demo is a video of starting with Google Cloud, creating a new Kubernetes cluster with Google Cloud, installing Fabricate on top of it, then using Fabricate to do various things. I'm going to fast forward a bit. So this is where we're 3 minutes in. So we've created a Kubernetes cluster on Google Cloud. We've installed Fabricate on top. And Fabricate's just booting up right now. And you can see it's downloading some images for Jenkins and Nexus and GOGS. So any second now, things should start up. Let me fast forward a little bit more. It's almost there. OK, Jenkins is up. Let me go to the Create Project Wizard. One of the other things about Fabricate is we have this whole raft of different apps you can install. So out of the box, we give you GOGS and Jenkins and Nexus. But we also have things like Gerrit, SonarQube, various chat applications, because you often want to use Slack or Hubot or something like that, so you can chat with your CI and CD system. We have things like Prometheus and Grafana and Kibana for doing centralized logging and centralized metrics. We have something called Chaos Monkey, which kills your pods, which is really kind of cool, because then you can test, is your software resilient? The idea is you're meant to run Chaos Monkey when you're in the office together, so that when things fail, you can watch it fail and you can try fix it. And then you're meant to remember to stop Chaos Monkey when you go home, so that you don't get a call at like 3 a.m. So the idea is meant to be to simulate failures while you're all in the office together. So then when you're at home in bed, you don't really get called so much. OK, so the video's screaming along. OK, we've got centralized metrics. Let's get to the project wizard. OK, here we are, project wizard. Right, so pretend I was doing this live. So we're creating a brand new project. At least I know this one's going to work this time. All right, well, I hope it is. I hope I've got the right video where it works. So we create a new project. We're going to pick a pipeline. The pipeline, I'll talk about the pipelines a little bit later, but the pipelines are defined in a file called a Jenkins file. It's a standard piece of Jenkins 2. Jenkins always used to be considered a CI tool where you can just do a single build job. With CD pipelines, it's all about having long-running jobs where you can do a build and you can do a stage and you can run system testing and load testing and you can run parallel steps or sequential steps. In this case, we're going to have a pipeline that builds a Docker image, runs a system test of that Docker image, deploys to the staging environment, then on human approval, it's then going to go to production. So the build started. I'm fairly sure this build's going to work on this video, or at least I hope it does. So what that's doing is it's cloning the source code, it's building the Docker image, pushing the Docker image into the Docker registry, generating the Kubernetes manifest for that version. It checks the Kubernetes manifest into Nexus. So every version of every microservice has all the POMs, all the jars, and all the manifests and the Docker image all tagged with the version number. By default, it generates the version number from Git tags on your repository. So it starts at 101, then goes to 102 and 103. If ever you want to do a minor increase, you just tag as 110, and then the next one's going to be 111, 112, and so forth. If you want to go to 20, you just tag with 20, and then the next release will be 201, 202, and so forth. The first build you ever do, you'll see lots of downloading of Maven of the internet if you do in Java. We use Nexus as a proxy cache so that when you're running this on your laptop or on a public cloud, we only download every Maven internet download once, and we cache it in the Nexus as a Nexus proxy. These are the environments that we define. Now, I remember doing a demo recently, and I heard someone mumble under their breath, "You had me environments." One of the things Fabricate gives you is every team has their own sets of environments. So every team out of the box gets testing, staging, and production environments. That's their own team, that the team can do whatever they want with, right? Each team can have many more environments if you wish, right? You might want soak testing, load testing, user acceptance testing. You might want lots and lots of different testing environments, possibly, depending on what your testing strategies are. But out of the box, we give you testing, staging, and production. This demo is just showing you a Node.js app now. So we've created a Java app with Spring Boot. We're now creating a Node.js app just to show that this is all polyglot. You can use any language, any programming framework. And so we're going to have two pipelines. One's going to be doing the Java stuff. One's going to do the Node.js stuff. One of the other things, so we create the Git repositories. We create the Jenkins jobs for the pipelines, and the pipelines are running. The other thing we do is we generate the webhooks so that whenever you do a Git commit and a Git push into master, it automatically triggers the CD pipeline to do another release. So right now, every time you do a Git commit, you get a new version released to production, and it automatically does the running upgrades. Here we're just looking at the source code. We have an inbuilt little editor so you can browse all the source code. Here we're looking at the pipeline. So pipelines in Jenkins are defined in Groovy, which is really groovy. It's a Groovy DSL for defining the steps that your build does. Here's the source code of the Spring Boot app. It's just a Hello World kind of Spring Boot application. I think later on in this demo, we're going to edit that code and change it. Yeah, OK. I might fast forward ever so slightly. This demo happens to be using camel, so we can visualize the camel routes, but let's not worry about that in this demo. OK, here's the Canary release going. We should see, you see it's gone to the staging environment. This pipeline doesn't actually have an integration test, I don't think, so it's gone straight to the staging environment. You see it's gone, you see the number 1 that's blue? When we start up containers on Kubernetes, things have multiple states. It starts as running, and it takes a little while to become ready. Ready, when it goes green, you see it's just gone green? Green means it's sufficiently warmed up to be ready to take HTTP traffic. One of the things Kubernetes offers is a liveness probe and a readiness probe. The liveness probe is like a health check to check, is the thing alive? If it's alive, that's all cool. As soon as it's not alive anymore, it kills the container automatically and restarts it. So you can detect things like if you have deadlocks on your process, or you're out of sockets, or your process somehow goes bad. If ever your process core dumps, Kubernetes will automatically restart it. But sometimes processes go bad, like they won't return HTTP traffic anymore, right? So liveness checks automatically restart your container if it fails. Readiness check gives you a chance to warm up your processes before the load balancer gives it traffic. If ever you do Java stuff, Java takes kind of like a minute to get going, right? As soon as you start running a Java process, it's not quite ready to take traffic. If your app is very data-centric and you want to do lots of quick response times, you might want to preload a lot of data into your apps before you serve traffic. So you can define your own readiness check that says, you know, I'm only ready once I've downloaded my product catalog into RAM or whatever for caching. So the liveness checks and readiness checks are a really nice way of doing load balancing nicely and automatically scaling things. So now we're looking at the runtime environment. So we're looking in the staging environment. So we've done the test, we've gone to staging. Let me just highlight what was just on the screen just then, I missed it. Here we're looking at the staging environment. We can zoom into the staging environment and look at all the containers that are running in any of these environments, right? So if you click on the pod icon, we can zoom into the staging environment. These are all the containers running in staging. So if I pause that a second. So here we can see we're running one Camel VM, that's just some Spring Boot and some Camel, and another Node.js app. Each container gets its own IP address, its own logs, its own metrics. So we can zoom into each individual container and see what it's doing, look at the logs. We can scale containers up and down. We can kill things if we think they look bad. But over time, we should be automating all of that kind of stuff. So we can click on any container that's running and look at its logs. You can open a terminal in any container and look at what's happening in the file system and so forth. We also have a Java console that lets you look inside any JVM at all the JMX metrics and things like that. So in Camel's case, we can look at the runtime Camel routes, if you ever use Camel. So we're looking at real-time message throughput inside a JVM, inside a container, inside Kubernetes. If you're using, say, JDBC or Spring Boot, you can look at all the various JMX metrics inside a running Spring application. So you can see how many requests it's processing, what are the requests going on, and all that kind of stuff. OK, so we've gone to staging. We've done the integration test. We've gone to staging. Now we're waiting for human approval. Oh, we're just showing the logs at the minute. So we have centralized logs and centralized metrics. So when you start running like 100 containers, you want to be able to do things like query all the logs across all your containers. So out of the box, we take all of the output from all Docker containers and put them into Elasticsearch. So then we can use something called Kibana to then query all the logs across all the containers and filter them by like which environment are you in, what's the name of your app, maybe what's the name of your container, any other key value pairs you've added to your app and stuff. You could filter the logs by version or whatever. Here we're just about to proceed with the human approval, and now we're going to go to production. So you see the production environment now has 101. It's gray because it's not quite running, it's starting. Now it's blue because it's running, and then soon it's going to go green to mean it's ready. Now we're switching to the Node.js app, I think. There we go, there's the Node.js app. So the Node.js app is in staging right now. We can test it. This is probably a really amazing web app. Yeah, look at that. It says hello. That's really amazing. Huge business value already. There we go. So you see the little open icon. So we can test any microservice in any environment by just clicking on it, and it opens in the browser, which is kind of nice. We're going to proceed with human workflow here. So now we're going to go to production in the Node.js app, and there we can see the Node.js app is going to production. Now notice we have two ways of looking at the screen. We can look at one microservice at once and look at its pipeline and its environments, or we can zoom up a level and look at all of the microservices in our team and look at and see what all of them are doing. Then we're going to edit the source code of the Node.js app and show how, by doing a git commit, we're going to do another release. We're going to get 102 of this application, and that application is going to have a new version of the Docker image, a new version of the YAML, and it's going to go through the testing, staging, production flow again. Here's the overall view. So we can see there's the integration app, and there's the Node.js app. And we can see which versions are running in which environments, how many containers are running in each environment, and what's the relative size of how many containers we are in each environment and stuff. This is a slightly old demo now. The Node.js app is actually using the git commit SHA as the version number, which is a little bit opaque and hard to read. We've since fixed that, so we now use nice, simple version numbers like 101 and 102, so it's much easier to understand the versions of things. Here we're doing a rolling upgrade in the staging environment. You see there's a new version started up. It's waiting for the new version to be running. Once the new version's up and running, the rolling upgrade is going to kill the old version. So we can see the rolling upgrade happening there for the new version of the Node.js app. Any minute now, that should roll over to the new version, and then it will go to the approval, and then we go to production. Okay. So just to recap what all of this video is doing, with a few clicks, we can create a microservice in any programming language with any framework. Immediately, that then goes to testing and staging and production. So without writing any code, without doing anything, you just made a choice of which technology you wish to use and which flavor of pipeline you want to use. And we take you to production immediately with each team's environments. Once you've gone that far, then you can use whatever IDE, editor, tools you wish to use to work on the source code. And then whenever you do a pull request or you merge to master, automatically the CD pipeline kicks in again. So development teams don't need to figure out, how do I do CD? How do I do CI? How do I do testing? How do I make Docker images? How do I deploy to different environments in Kubernetes? We've automated the entire end-to-end lifecycle with centralized metrics, centralized logging, loads of dashboards and feedback, and the entire end-to-end pipeline is automated for you. There's a few more demos here of various dashboards and whatnot, and nice charts of all the various things you can look at, like what's the difference. This is slightly embarrassing to Java people. What's the different memory consumption versus Java versus Node.js, because Java tends to be a little on the large side compared to Node.js. And there we go. Right, I'm going to pause the demo right then. I'm going to pop back to slides. If I could, oh, I'm in the video, not the browser. Let me quit the video. There we go. No, that didn't quit it. Right, we're back. Oh my God, what's going on? Oh yeah, I was in the web browser, wasn't I? Okay. Phew, okay. Oh, I guess I didn't really show you, this is the Git repo of the thing we generated. So you can use the GOGS front end to view the source code, a bit like your own private GitHub. So you can view all the commits going on there. You can view the Jenkins console, which in our case failed. But we can look at the Jenkins console. So this is vanilla Jenkins. And we can see how badly the demo worked when I ran it on my laptop. This is the new Blue Ocean front end to Jenkins, which looks really slick and nice when it actually works. If ever you don't like the new funky view, you can look at the old traditional view, which is probably a bit more familiar, like the old style Jenkins view. Okay, let's go back to the slides. So what we saw there was we created projects, we edited code, the CI worked, the CD worked in the video, and everything went to production with testing, staging, and production with optional human approval. So I just wanted to walk through what are the actual technologies. Well, how do you install it first? So if you want to try this on your laptop, I promise you it will work better than my demo did. To install it on your laptop, go to fabricate.io. I've opened the webpage here. Here's fabricate.io. If you scroll down a little bit, there's an install locally button, and there's an install on the cloud button. If you just want to try it on your laptop, click on the install locally button, which is this page, and basically just read through these instructions, but basically you download this binary called Go Fabricate for your platform. There's a binary for Linux and Mac and Windows, and then you run this command, Go Fabricate start. What that then does is it downloads some software called Minikube, which then boots up a Kubernetes cluster on your laptop, and then installs Fabricate on that cluster. So you basically have a single VM with a Kubernetes cluster running on it, and then Fabricate boots up on top of that. Then the console starts, and then you can start creating projects and stuff. And hopefully your demo will work better than mine did today. Right, so that's how you get started on your laptop. If you want to install it on the cloud, there's various different options. Red Hat has OpenShift, which you can download and install. There's something called StackPoint that lets you spin up a Kubernetes cluster on Amazon, Azure, Google Cloud, and DigitalOcean. Have a little noodle of the website. There's a ton of different options for you to do. If you have a Kubernetes or OpenShift cluster already, you just type Go Fabricate start, and it will automatically use whatever cluster you've previously installed. So use any method you like to create your Kubernetes cluster. Go Fabricate start should work on that cluster. Right, so that's how you install it and run it yourself. I just want to talk about the actual technology under the covers. So Fabricate stands on the shoulders of three big giants, really: Docker, Kubernetes, and Jenkins. So I'll do Docker first. So Docker, you've probably heard about Docker. We've all heard about Docker over the last kind of 4 years. It's revolutionized how we really release software. In the old days, we used to write like Word documents of how to run commands and shell scripts and all sorts of horribleness to install software. Now we can just make a single immutable binary Docker image and then run that image trivially with lots and lots of tools. So here's the standard Docker command line to run anything that has a Docker image. So this can run Ruby, Perl, PHP, Erlang, Java, .NET, pretty much anything that can be packaged, or pretty much every database, okay, maybe not Oracle, apart from Oracle, pretty much every database that we can use today can be started up like this. So Docker run is a nice, easy way of running anything using a Docker image. So if you want to go fast and we want to be repeatable, Docker images are the ideal format to release your software in because anybody can take that image and just run it on their laptop, on a cluster, or on Kubernetes, or whatever. The challenge is, how do we run lots and lots of different microservices on lots and lots of machines, and how do we reliably keep that stuff running over time? And this is where Kubernetes comes in. So Kubernetes was created by Google. Google have got a pretty good track record of running containers in production. They've been doing it for about a decade at extreme, monstrous scale, which is beyond what most of us will ever dream of, really. Internally, Docker's container cluster orchestrator thingy is called Omega. If you want to read more about it, they did a really good paper recently, the Omega paper from Google. So have a little noodle of that. What the Googlers kind of did was they felt that the entire industry should benefit from their expertise in Omega. So they created Kubernetes as like an open source, reusable Omega for the masses. So you can think of it as Google for everyone else. They started the project about 2 years ago. It's now pretty much the most active project on GitHub. It has, I think, the most pull requests of any GitHub project ever right now. It's insanely active. There's a ton of contributors from Microsoft, from Red Hat, from CoreOS, from Apprenda, from a ton of different companies. I think IBM, Pivotal have now joined the Kubernetes club as well. So pretty much everybody apart from Amazon is now on the Kubernetes bandwagon, which is really, really awesome. So what does Kubernetes do? It really just runs containers on a bunch of machines, right? That's kind of really all it does. You can give it a Docker image and say, run this 5 times, and it will keep them running, right? This is the Kubernetes version of the Docker command line. kubectl is like the command line tool for Kubernetes. People they pronounce it kubectl, which is kind of nice and cute. So kubectl run, you give it some name, you give it an image, and then you see the minus replicas equals 5. That will say run 5 replicas. In other words, 5 processes for your Docker image. So what Kubernetes does is it says, right, I'm going to run 5 of these things. So it spins up 5. And then if ever one of those processes dies, or you lose the box that was running 2 of them, Kubernetes is constantly monitoring how many instances are running all the time. And if ever the number of instances dips below 5, it spins another one up. If for some wacky freak incident there's now 6 running for some reason, it will tear one down. So it will always keep 5 running all the time. So you don't have to keep running like PS commands and grepping it to see, how many am I running? How many am I running? And then manually starting and stopping stuff. Kubernetes can keep your stuff running for you, right? It's like magic. It's awesome. Kubernetes does a whole raft of other things as well, like load balancing across all your containers, so you can consume these 5 things as if it's one logical service, and various other bits and bobs. Here's a little architecture diagram of what Kubernetes looks like. There's like a logical master that you talk to that via the command line shell, via a REST API, or via the web console that lets you view all of the different containers, scale up or scale down your containers, define load balancers, and all those kind of things. There's a whole raft of different resources you can work with, like you can manage your secrets for your like tokens and login and passwords and all those kind of certificates and stuff like that. In Fabricate, for example, we need certificates to log into Jenkins, we need certificates to log into the Git repository, and we need certificates and user passwords and tokens to be able to deploy into Nexus. So we've wired together Jenkins, the Git repository, and Nexus with Kubernetes secrets. So we can start up all of these different pods, and they all just work together without you having to type in login and password or anything, right? So Kubernetes deals with secrets, it deals with configuration, it deals with persistent volumes in a really nice, simple way. One of the things I particularly love about Kubernetes is it's kind of small. When you start reading the Kubernetes docs, it might kind of look big because it does lots of stuff. But in terms of software, Kubernetes is a small daemon called a kubelet that just runs on every machine, and the kubelet decides and controls what processes run on one box. So you have this fairly small daemon that just runs on every box, and all that daemon does is really start and stop Docker containers and monitor what's happening on the local machine. So a Kubernetes cluster is a pretty low, simple piece of software you run on your machines that turns your machines into basically a container cloud, which is really, really cool. Okay, so that's Kubernetes. So we use Kubernetes, we use Docker to package things. We use Kubernetes to run containers at scale. One of the other things Kubernetes does is something called namespaces, which lets us do the environment thing, right? In a namespace is like you're logically segmenting your cluster. So in the test environment, none of the containers in there can see production. They can only see the test environment. In the staging environment, all the containers can only see the staging environment. They can't see production. So you can deploy the exact same Docker image to each environment, and you don't accidentally talk to the production database in the wrong environment, right? Everything just works. You don't have to do dollar squigglies or magic search and replaces of random shell scripts. You can just take your app and deploy it in every environment, and it will just do the right thing, which is really, really awesome. Okay, the third big giant that Fabricate sits on top of is something called Jenkins. How many people use Jenkins right now? Most people say, yeah, good crowd. Most people use Jenkins, right? But most people have been using Jenkins for like a decade or many years and using it as a CI server, right? So it runs your tests and it might do a release, possibly. Last year, Jenkins 2 came out and it added something called Jenkins pipelines. And Jenkins pipelines are really, you can think of it as kind of like workflow for your releases. And it's like a workflow engine where you can define multiple steps, like create a Docker image, run a system test, run a load test, wait for human approval, stage to staging, stage to production, and so forth. How it works is there's a new file format called a Jenkins file. So like make has makefile and rake has rake files. Jenkins has Jenkins files with a capital J. You check the Jenkins file into your source code, which is a new thing. So your Jenkins file defines how your pipeline, your continuous delivery pipeline works. So how you want your builds to work, how you want your tests to work, how you want your approvals to work, and your staging and promotions. One of the really interesting things is now we're versioning the Jenkins pipeline. I don't know if this has ever happened to you, but it's happened to me a lot. When you're using Jenkins in the traditional way, you have a build and it's working brilliantly, and all of a sudden one day the build fails because someone somewhere changed something at some point and nobody knows who changed what, when, where. By putting the Jenkins file in Git, every change to the Jenkins file is versioned, so you can roll back changes and you can see who changed what. So if all of a sudden your pipeline breaks, you can see, in fact, I'm going to look at Git fairly soon to see why my demo failed. But in other words, we can use Git to see why things, we can version things so that, for example, if one microservice team wants to upgrade from Maven 3.2 to 3.3, you can update the Jenkins file for one project and leave all the other projects the same. So it lets you, each microservice can then version itself independently, right? Some teams are going to go really, really quick with microservice and be racing the latest Maven and the latest Go and the latest whatever. Other teams are going to kind of stick on the crusty old version of Maven and they're not going to move because it works and they're just going to leave it. So it lets each microservice team move in whichever speed you wish. One of the other things about Jenkins files is you can have reusable libraries of functions. When we first started writing Jenkins files for our pipelines, we would just do everything almost like on the command line. We'd run like Maven deploy, and we'd do Maven this and Maven that. And we just had everything quite descriptive, and it was kind of quite long. And then as we'd done like 2 or 3 or 4 pipeline Jenkins files, we realized most Jenkins files are kind of the same stuff all the time. So we started to refactor these Jenkins files to make them reusable. So we now have a library of reusable functions you can use in your Jenkins file. And then we have a library of reusable Jenkins files. So in the user interface you saw where you were given a list of Jenkins files to pick, that's literally just a library of Jenkins files indexed by technology type. So we have Jenkins files for Node.js, Jenkins files for Ruby, Jenkins files for PHP, Jenkins files for Maven. What we found is the Jenkins file for all Java projects are basically the same. Like any Java project using Maven, we kind of do the same stuff on all projects. So you don't really have to create the Jenkins files for every different project. You just kind of go, are you using Maven? Okay, we'll use the Java one then. So each team doesn't have to sit there and study Groovy, although that's kind of fun if you want to do it. But you don't have to learn Groovy. You don't have to learn the Jenkins file syntax. You can just reuse a library of Jenkins files. If you're a fairly large software organization, what you could do is just have one team just own the pipelines and develop the pipelines for everyone else so that developers can just sit there writing PHP or Groovy or Java or whatever and let another team focus on the CD pipeline piece for you. So you could have one team that just do pipelines on behalf of other people so everybody can go kind of quick. But this two-level of reuse. You have reusable Jenkins files, and you have reusable libraries of functions which you can use in your Jenkins file. You can just use our libraries out of the box, but you could also fork it to add your own functions. We found, as we started to automate more and more of what we do with our CD pipelines, in the early days, we kept things quite simple, but we've gradually got more and more clever as we realize how much manual stuff we have to do right now. For example, when we're releasing our 200 Git repositories, what we used to do is release the first repository, manually wait for it to be Maven Central, then when it was in Maven Central, we'd go to the next project and edit the source code with a new version. Then we'd release it, then we'd sit and wait for that to be released. Then we'd go to the next project and edit the source code, and we do all of that manually. I think most teams update their versions manually by hand, which if you think about it, that's insane, right? So now we have a pipeline that whenever the first release goes out, the pipeline waits for the release to be synced to Maven Central, so it's reusable. Then immediately it generates pull requests on all the downstream projects. So we automate the generation of pull requests across all the downstream projects. Once you raise a pull request on the downstream projects, that kicks off the CI pipeline, which is automated with Jenkins files again. That runs all of the tests on the downstream projects to say, does the new version work or not? If the pull request fails, the upstream pipeline knows about it, it sees the failure, reports the failure into Slack, so then we get a notification that this new version has broken a downstream project. Ideally, when things are working well, it just flows through all the projects. So we can do a complete 200 repo release in a period of a few hours. I took quite a few hours for all the pull requests to merge and stuff, but it's basically all completely automated. We've been through various experiments on this, but we found that aggressively pushing version dependencies to repositories that want to accept those pull requests is a really nice way of testing early, right? As soon as I do a release, I want to know, does my release break anybody downstream? If I do, I want to know about it, because then I might need to do a new release that fixes it. So the more we can do this automated version dependency upgrades across projects, the better it is we get more feedback and we can go faster, right? So I highly recommend you all look at Jenkins pipelines. They're a wonderful thing. The easiest way of getting started is just to reuse Fabricate, quite frankly. Okay, I'll speed up a little bit because I'm almost out of time, and I'm going to try to leave a few minutes for questions. So the three main pieces of technology in Fabricate are Docker for packaging, Kubernetes as the container as a service platform that you run everything on, and then Jenkins pipelines as the thing that does the CD and CI. I didn't mention it in the demo, but we've increasingly started to do CI and CD with the same pipelines. So that we can automatically generate CI jobs. So whenever somebody does a pull request on master, we use the same pipeline technology to run the test to check that master is clean, that then allows that pull request to merge to master, that then triggers a CD pipeline. So we can do CI and CD with the same kind of pipelines, and we just have functions that tell us are we in a CD pipeline or not based on the branch you're in and stuff. So Docker, Kubernetes, and Jenkins are the big three technologies. But there's a whole raft of other technologies we've integrated as optional microservices you can choose to opt into or out of, such as on the logging front. If you want to do logging, Elasticsearch is pretty much the leader in the log space. A lot of cloud providers have their own logging services. Amazon do, Google do, Azure do. So if you're using one of the public clouds, you might want to use the native logging service on the cloud. If you're using on-premise stuff, you can run Elasticsearch as the backend to store the logs and events from your system, and then use Kibana as a nice front end. And again, we've integrated all this into Fabricate. It's literally just click the run button, choose logging, and click run, and it just deploys all this stuff for you in Kubernetes. Similarly, there's Chaos Monkey, which is fun, and Prometheus for metric collection. Quick example of dashboards, which we saw in the video as well. This is showing various different commits, deployments, running upgrades, and logging events. Here's a more traditional metric kind of thing where we're looking at like CPU, memory usage, and so forth. The next level in of understanding how services behave is something called Zipkin, which you might want to, or open tracing and Zipkin. One of the classic problems with microservices is once you start invoking lots of different microservices, and all of a sudden your application starts slowing right down, it can be hard to know why. So by using open tracing and Zipkin, you get visualization of what's the call graph of your microservice, so you can see where the slowness is coming in. And also you can see what the real service dependencies are. Your service might invoke a service A and a service B, but you have no idea what A and B do. By using Zipkin, you can trace all the way through your call graph and see what's really happening over time. And the more microservices you do, the harder this is to understand unless you're using something like Zipkin. So have a look at Zipkin and open tracing. It's really, really useful. Another kind of thing that's popular these days is circuit breakers with things like Hystrix, which is a library you can use from Java that lets you essentially do like retry handlers and timeouts so that you can still give a decent quality of service to your end users. If one of your downstream services is behaving badly, you can fall back and use, for example, cached data or dummy data or whatever. Increasingly, we're hoping to see things like circuit breakers and client-side load balancers as more of a service we can just use out of the box in Kubernetes. There's various projects like Linkerd and Envoy that do this more at the service level in Kubernetes. ChatOps is getting increasingly a common way. As we start working in a more microservices world, we have lots and lots of teams all iterating quite quickly, and it can be quite hard to keep a team in sync of what's happening. So chat is quite a common thing. I think most of us spend our time in chat these days with our teams. By integrating your CI and CD pipelines with chat, you can see when releases happen, when releases fail, when rollbacks kick in. You can get alerts to go to chat. Over time, the challenge becomes how do you filter the chat so that it's not too noisy, but at the same time gives everybody a good visualization of what's going on. I'm almost out of time, but I'll just do a very quick thing of how do you develop on something like Fabricate and Kubernetes. I think when developers first see Kubernetes for the first time, it can take a little while to comprehend what it is and how you use it and what you should do. One of the lessons of using Kubernetes from a couple of years is we spent quite a lot of time in the early days trying to run software locally on our laptops on like Windows or macOS and pretending our laptops was part of Kubernetes, and it was just a disaster. Because as you start really using Kubernetes for things like load balancing and discovery and wiretaps and API gateways and auto-reloading and DNS discovery and persistent volumes and secrets, and the more you start really using all this amazing stuff in Kubernetes, the harder it is to pretend when you're not on Kubernetes that it's the same. And eventually you come to the realization, unit tests are fine, and we should all do unit tests, but once you move beyond unit tests, you should run everything in the most production-like environment, right? So as Java folks, we should stop trying to run things on our Macs or Windows boxes. We should run everything on Kubernetes whenever we can, right? So what we wanted to do was make Kubernetes feel like it was on your laptop and you were just doing normal stuff. So we have a Maven plugin, which is just a normal Maven plugin. If you're using Maven and Java, you can type the first command, and that will automatically add the Maven plugin into your POM. It's just one Maven plugin. If you don't have Kubernetes installed yet, you can type Maven Fabricate cluster start, and it will boot up Kubernetes for you on your laptop, or you can use Minikube. But the most important line is the one at the bottom, Maven Fabricate run. If you've ever used the Spring Boot plugin, Maven Spring Boot run, or if you used Tomcat, Maven Tomcat run, or Wildfly, Maven Wildfly run, or Carafe run, every app server and framework has a run. Jetty run, I missed Jetty, I apologize, Jetty guys, they're here. Jetty run is another plugin. Pretty much every app server framework on Java has a Maven plugin that has a run option. We've mimicked that with Maven Fabricate run, and what that does under the covers is it generates a Docker image for your Java project based on your local source code that's on your file system, generates a Docker image, pushes it into Kubernetes, generates the manifest for running that in Kubernetes, deploys it in Kubernetes, and then the cool bit is it then tails the log of the newest container that's running in Kubernetes. So it looks like it's running on your laptop, right? You type Maven run, and then you see it running on your laptop, and you see the log of your running container. And then if you hit Control-C, it scales down the running container on Kubernetes. So it looks like you're running a local process. But actually, it's all completely running in a Linux container on Kubernetes as production would be. So it gets developers out of this habit of running stuff on a totally different JVM and a totally different operating system with totally different networking, with totally different secrets and volumes and all this kind of stuff. So it gets us into the habit of run the stuff that you're going to run on production. Because if we're not doing that, you're going slow. You're testing on something that isn't production. So you're probably wasting your time. You're probably missing threading issues and persistence issues and network issues that as soon as you get to production, you're going to hit them. So just miss that out, right? Go faster. Go straight to production. So that's how you can develop locally. quick thing on service discovery. When you want to do service discovery in Kubernetes, this is a thing that people start going, how do I do that? There's a blob of YAML you can use to define services in Kubernetes. Basically, what you do is you use a selector, the thing right at the bottom, to select which containers you want to talk to, and you give things labels so you can find them. You expose ports from a container, and then to use it in like Java code or PHP or Python or Perl, you just use a URL, like in this case, http foo-bar. You use just the DNS name, foo-bar for the service name. Under the covers, Kubernetes matches that to the service IP address. Each service gets a fixed IP address, so there's no DNS caching issues or anything. Then when you use that fixed IP address, under the covers, Kubernetes maps that fixed IP to a dynamic real-time list of the physical pod IPs or the container IPs. So what you basically get is free dynamic loading. So you can start and stop containers, run them anywhere you like. Your app will automatically load balance over all the containers, which is awesome. The only thing you have to be careful of is if you're writing any code that's invoking something of the network, that process can fail, right? So if you're talking HTTP over a socket, the thing you're talking to could fail, so you have to do retries and stuff like that. But apart from that, it's just really simple. So service discovery is just there. You don't need any dollar squigglies or any kind of weird magic. Just use DNS. And there we go. So quick tip on logging. Please use standard out. As Java people, we're quite used to having these rolling appenders and log files in magic folders and all that kind of crap. Get rid of all that. Use standard out. You get extra brownie points if you use JSON. So output JSON strings to standard out. Then all of that output can be slurped up by any container platform and put into the logging layer. Metrics, if you use Java at all of the Fabricate wizards automatically add something called a Prometheus collector that collects all of the JMX metrics, in addition to all of the Docker metrics and all the operating system metrics. So all the metrics in your process will be automatically collated and stored for you if you're running a management platform. And that's pretty much it. Testing, I mentioned this briefly. If you've ever done Java stuff and you've ever used Archillion traditionally was done for in-container testing, but in this case, it wasn't meant to mean Docker. It was testing a war inside Tomcat or Wildfly or something. What we've done is extend Archillion to do in-container testing, as in Docker container testing, so we can test your app in Kubernetes. So rather than testing on a Mac, JVM, which is totally different, you can test your app inside Kubernetes in a real container using real Kubernetes manifest. And you can write one line of code, which is pretty cool, that asserts that your deployment starts up, that your liveness probes work, your readiness probes work, and your app stays up without restarting for about 10 seconds. Now, ideally, you should write more than one line of code in your tests, but this is like a start that checks at least you haven't messed up the manifest, and you haven't messed up the Docker, and you haven't messed up the class path, and your stuff actually starts. Okay, so in summary, my demo will work next time, I promise. But watch the videos online if that wasn't totally clear. There's loads of videos online. Go to fabricate.io if you want to learn anything about Fabricate. Please download it and try it out and see what you think. Let us know on Slack or IRC or GitHub issues or whatever. Any feedback you have, things you like, don't like, whatever. Red Hat are investing heavily in Fabricate right now, and there's some amazing stuff going to happen this year that I can't talk to you about. Although if you buy me beer later, I might let slip a few things. But I'm not meant to say anything at all about what's happening. But there's going to be some amazing stuff happening this year. We're extending the reach of Fabricate to do more and more stuff for developers. What we're really trying to do is make developers productive on top of things like Kubernetes, right? Kubernetes is amazing operational infrastructure for doing stuff. But it's maybe not the easiest thing for developers to use, right? What we're really trying to do is optimize the developer experience on top of Kubernetes to make it super simple for developers to create microservices, edit them, debug them, test them, but most of all, get to production quickly and iterate a lot and get feedback. So thank you for coming. I'm here all day today and tomorrow-ish. So come and talk to me if you have any questions or queries. Thank you and enjoy the rest of the conference. Thank you.